So let's read the question. E and F are respectively the midpoints of equal sides AB and AC of triangle ABC. So basically, we have a triangle ABC in which AB is equal to AC and E and F are midpoints of AB and AC. Based on this, we have to show that BF is equal to CE, right? So let's begin. So see, what do we have to show? We have to show that BF is equal to CE. So basically, we have to show two sides to be equal. So what is the logic? Look for two triangles which have BF and C as their sides. So I want a triangle with BF as its side. I can take triangle BFC. I want a triangle with C as its side. I can take triangle CB. So let me mark these two triangles. First, I want a triangle with BF as its side. So let me first highlight BF. I want a triangle with BF as its sides. So I can take this triangle over here, BFC. Right? Next, I want to show BF equal to CE. So highlight CE. I want a triangle with C as its sides. So I can take this triangle over here. So BC is my common side. Right? So basically, if I can show these two triangles to be congruent, my job will be done. Right? Now, once you've understood this, let's begin with what is given to us. What is the first thing given to us? AB and AC are equal sides. So right over here, AB is equal to AC. Now, the moment you get equal sides in a triangle, recall the theorem, in a triangle, if two sides are equal, the angles opposite to these sides are also equal. So the moment you see a triangle in which two sides are equal, immediately mark the opposite angles as equal. So what is the angle opposite to side AB? It is angle AC over here, this entire angle. What is the angle opposite to AC? B. That means angle B is equal to angle C. So I'll write over here, angle B is equal to angle C. To avoid confusion, I'll use the three-letter name. That is angle ABC is equal to angle ACB. Right? Now we have to write the reasons for all of this. AB is equal to AC. This is given to us. Angle B is equal to angle C. State the theorem over here. That is, angles opposite to equal sides are equal. So remember, whenever you see a triangle in which two sides are equal, immediately mark the opposite angles as equal. Next, what is given to us? E and F are midpoints of AB and AC. Since E is the midpoint of AB, that means AE is equal to EB. So I'll mark over here, AE is equal to EB. Similarly, F is the midpoint of AC, so AF is equal to FC. So AF is equal to FC. Again, this over here is given to us. Why? E and F are midpoints. So you can write over here, given. Right? So it's very, very important to understand what is given to you. We're given AB is equal to AC. I wrote it down. The moment I saw two sides are equal in triangle, opposite angles are equal. Next, we're given E and F are midpoints. E is the midpoint of AB. That means A is equal to EB. F is the midpoint of AC. So AF is equal to FC. Right? Now, if you notice, AB is equal to AC. I repeat, AB is equal to AC. So half of AB will be equal to half of AC. I repeat, copy this over here. See, AB is equal to AC, right? That means if I multiply both sides by half, still the equation is the same. So half of AB is equal to half of AC. What is half of AB? Half of AB is basically either AE or EB. That is, A is equal to AB. So I'll just rub this off. This is nothing but half of AB. Similarly, AF is equal to FC, half of AC. Why? See, these two sides are equal, right? So let's say this is X and this is X. So what is total AB? X plus X, 2X. What is AE? X. So X upon 2X, half. So remember, whenever you have a midpoint, this is equal to this and each part is half of the total length. I'll explain once again. Let's say this is 10 centimeter. Let's say we have a line segment AB, which is 10 centimeter. C over here is the midpoint. That means AC is 5, BC is 5, right? So 5 and 5. Now what is AC upon AB? AC upon AB. AC is what? 5 centimeter. Upon AB, that is 10. That is half. So AC is basically half of AB. Similarly, A is equal to EB. So A and EB both are half of AB, right? So right over here, given. So what am I interested in? See, basically I have to prove these two triangles is congruent. So I want to get EB is equal to FC. That is what I'm getting from here. So what is half of AB? It is EB. is equal to half of AC, that is FC. So I've got EB is equal to FC, right? So this over here, I'll call it 1. Angle B is equal to angle C, I'll call it 2. So now let's proceed towards congruence of these two triangles. So let me first rub this off. So now we have to prove these two triangles to be congruent. So write down their names. That is in triangle EBC and triangle FBC. What all do we know? First of all, EB is equal to FC. So I'll write over here, EB is equal to FC. How did I get it? From 1. So mention in bracket from 1. Next, we have this angle is equal to this angle. So I'll write over here angle EBC is equal to angle FCB. From where did I get it? From 2. That is angle B is equal to angle C. So just name it as per the triangle. I repeat, that is because our triangle is EBC. So instead of writing this as angle ABC, write it as angle ABC. Right. Next, what do I know? BC over here is a common side. BC is part of the red triangle. BC is also part of the blue triangle. So BC is equal to BC. What is the reason? Common side. So what do we have? In two triangles, two sides are corresponding and the included angle is also equal. So by SAS criteria, the two triangles are congruent. That is side, angle, side. Side, side, included angle. So by SAS criteria, the two triangles are congruent. So therefore, now how do we write the congruent statement? Triangle EBC is congruent to triangle. See, EB corresponds to FC. So FC, what remains? B. And BC corresponds to BC. Angle B is equal to angle C. B is equal to C. That is 1, 2, 3, 1, 2, 3. So 2 corresponds to 2. B is equal to C. EB is equal to FC. BC is equal to BC. Right? What is the criteria we've used? SAS. Right? So by SAS criteria, the two triangles are congruent. Once the two triangles are congruent, what do we want? We want to show BF is equal to C. So get BF and C from your congruence statement. How do I get it? I'll rewrite the congruence statement over here. Triangle EBC is congruent to triangle FCB. So just write down 1, 2, 3, 1, 2, 3. Now what do I want? BF is equal to C. So search for either BF or C in your congruence statement. Let's say I search for BF in my congruence statement. BF. BF is over here. So BF is what? First and third letter. So first and third letter will correspond to first and third letter over here. So what is first and third letter over here? BF. This will correspond to first and third letter over here, that is CE. So from here we get BF is equal to CE. What is the reason? CPCT, corresponding parts of congruent triangles. So hence proved. So hence we have proved that BF is equal to CE. Right? So I repeat once again. See, whenever you want to show any two corresponding sides as equal or angles as equal, that means we have to take the help of congruence. So search for two triangles which have these parts. For example, here I wanted to show that BF is equal to CE. So choose triangles which have BF and C as their sides. So I chose triangle BFC, the blue one, which has BF as its side. I chose triangle CB, that is the red one with C as its side. Now I want to show these two triangles as congruent. That is the first thing you have to understand. Now how do I show these two triangles to be congruent? It will always be given to you. Pay attention on what is given to you. First of all, we are given AB is equal to AC. Write it down. The moment you see two equal sides in a triangle, immediately mark the opposite angles as equal. Why? Angles opposite to equal sides are equal. Next, we are given E and F are midpoints. That means A is equal to EB, which is half of AB. AF is equal to FC, half of AC. Right? This is done. Now, in these two triangles, I am interested in EB and FC. So what is EB? Half of AB. What is FC? Half of AC. So what I did is, I multiplied both sides by half. So half of AB is EB, half of AC is EC. So from here I got EB is equal to FC. Next, these two angles are equal. What can I say about BC? It is the common side. So two corresponding sides are equal and the included angle is also equal. So by SAS criteria, that is C, EB is equal to FC, BC is the common side and this angle is equal to this angle. So side, angle, side, the two triangles are congruent. Once the two triangles are congruent, use CPCT to get the corresponding parts. So I want BF is equal to C, BF is first and third letter. This will correspond to first and third letter. So BF is equal to CE. CPCT, corresponding parts of congruent triangles, hence proved. Right? So the logic is that whenever you want to show two corresponding sides as equal, get two triangles, which have those as their part, show them to be congruent. By CPCT, you'll get your answer. Right? So this is how you solve this question. I repeat once again, the moment in a triangle you see two equal sides, mark the opposite angles as equal. Very important. Right? So this is how you solve this question.